Hello everyone, I am Srikari Veerabhatla. Today I want to talk about my project Elevating Smart Home Security and Innovative Multi-Factor Authentication Technique. As part of our discussion, I will first talk about introduction to smart homes, then the problem I encountered with the security authentication issues, and then I will explain my proposed solution with a clear picture of design and implementation, and then conclude with its strengths and weaknesses. So let me introduce smart home. Generally, a smart home is a living space where devices like lights, thermostats, and electrical appliances are connected to the internet, which enables remote control and automation through smartphones or any other smart devices. It aims to enhance the convenience and efficiency by allowing these devices to communicate and work together seamlessly. With the recent developments in technology, security and its authentication systems are getting integrated into smart homes. The main advantage is to avoid the unauthorized intrusion into the smart homes. Most commonly used security systems have single factor authentication, such as username and password, or any PIN generation to smart device, such as smartphone. But developments in technology also increased threats to such authentication systems where hacking the password, especially when it's weak, or hacking the smart device is becoming a common occurrence. A single factor authentication technique also becomes problematic if user forgets his password or his connected smart device, since there is no backup plan in such cases. This is the problem I encountered and started working on it. My proposed solution includes four different authentication factors, which are dynamic pin generation, fingerprint recognition, ear shape recognition, and gesture recognition, with the final one as a backup plan. This technique provides more security as it has four different layers. To propose this solution, I used rapid application development methodology, in which user feedback is considered to select different authentication factors and design the flowchart for my proposed solution. In the authentication process, users begin by scanning their fingerprint and ear shape. Once the system receives the input, it checks the database for registered prints. If registered, it generates a DPIN and sends it to the user's mobile and unlocks the door upon successful entry. But what if the DPIN does not match, or if the registered mobile is not available? Then the system requests the user for the gesture, and once the gesture is scanned, it starts searching for it in the database, and if matched, the system unlocks the door automatically. But what about the new users? New users can press no for the initial authentication in the first step, and the system checks if they are the current owner. Once authorized as admin, the system requests for the registration of fingerprints, ear shapes, gestures, mobile number, and saves the information directly into the database. The authentication process then follows the same steps as for the existing users. In case of intruder, checks are placed at various stages, and admin will automatically receive a message if there is any authentication failure at any stage. By using this flowchart, system prototype is developed. The key components I used here are a keypad to enter the DPIN, LCD display which displays the output, ESP32 camera to scan the user biometrics, and finally a GSM module to send any alert through notifications. This prototype is tested and a survey is conducted. Based on the survey results, the accuracy of individual techniques ranges from 65 to 73%. However, the combined MFA technique achieves accuracy of 85%, which is higher than any other technique. The main advantage is enhanced security, preventing unauthorized access while providing user convenience. But there are also limitations for this technique. Implementing and maintaining this hardware intensive solution needs careful attention. Dealing with different algorithms adds its own challenges, highlighting the importance of consistent and thorough maintenance. In conclusion, a comparative analysis led to the development of new MFA technique that combines the strengths from various authentication methods. But real world implementation requires collaboration with industry partners, continuous development of security protocols, and a collective effort to fight against cyber threats, which will be done in future. And here are the references I used for my research. Thank you for listening.
Everyone, my name is Saujanya Bhimani. I am currently pursuing my Master of Science in Computer Engineering at San Jose State University. Let's quickly dive into our topic, cloud computing. Cloud computing is rapidly transforming how organizations access and manage computing resources. In the next few minutes, I will provide an overview of what cloud computing is, its different models, benefits, and challenges. So, why cloud computing? Let's think about starting a new company. Initially, resources are limited. As you plan to set up IT infrastructure, you realize that significant investments are needed for servers, hardware, networking, electricity, cooling, data center space, etc. This complex setup takes months too. Instead, we can leverage the cloud. This saves time and money by renting these resources from cloud providers rather than owning them ourselves. We can start small and easily scale up and down based on demand. Coming to on premise, the on premise model requires significant upfront investment in hardware, software licenses, data center infrastructure, and skilled staff to install and manage it all. Ongoing operating expenses like electricity, real estate, maintenance, etc., further drive up costs. Capacity is constrained to what the equipment allows. Scaling requires lengthy procurement and provisioning cycles to deploy additional physical servers and storage. The downtime risks are also higher. Lack of agility around making IT changes, limited accessibility imposing collaboration hurdles, considerable time setting up hardware and software components all weigh down teams. Whereas cloud coming to cloud computing, the cloud services are purchased on demand, allowing businesses to launch initiatives quicker without sunk infrastructure costs using flexible pay as you go billing that scales seamlessly based on real usage. Automation and self service access drive faster implementation measured in minutes or hours versus weeks or months. Built in resilience from redundant data centers, connectivity facilitating global teamwork, up to date technology with no disrupt upgrades. Cloud disrupts traditional approaches using shared, easily available resources. The cloud value proposition resonates with enterprises, making it rapidly expanding $500 billion market. Adoption is clearly accelerating as organizations recognize how cloud enables them to become leaner, faster, and more innovative. What is cloud computing? Cloud computing means storing data and running applications using remote servers on the internet instead of on premise infrastructure. You don't manage anything locally. With internet connectivity, you can access these resources from anywhere. Coming to the objectives of cloud computing, the key aspects are on demand access, network availability, resource pooling that enables sharing between organizations, elasticity to quickly scale, and usage based billing, only paying for what you utilize. Coming to the benefits of cloud, multiple drivers make cloud adoption compelling. Businesses can provision resources in minutes to respond faster to needs, reduce upfront infrastructure costs significantly, easily scale capacity on demand, and enhance security around sensitive data. Coming to the cloud providers, leading technology vendors like Amazon AWS, Microsoft Azure, IBM Cloud, Google Cloud Platform, and Oracle Cloud compete by offering platform services, tools, and global infrastructure to power cloud solutions. Coming to the cloud architecture, a typical cloud setup has three sections: a front end portal for users to access the cloud environment, a backend with servers and data storage, and a network to connect them. This is managed by the cloud provider. Coming to the big concept, it has five essential characteristics: three deployment models and three service models. Cloud computing characteristics are on demand self service, resource pooling, measured service, broad network access, and rapid elasticity. Coming to the types of cloud computing, it has the three deployment models and three service models. The deployment models, namely public cloud, private cloud, and hybrid cloud. Public cloud. The public cloud infrastructure is hosted by third party cloud service providers like AWS, Microsoft Azure, or Google Cloud Platform. It allows the general public open access over the internet to leverage these shared computing resources on demand via self service interfaces on a pay as you go billing model without having to set up any hardware on premise. Public cloud offers immense flexibility and agility to deploy workloads as services accessible from anywhere without upfront capital investments. The responsibility of managing the underlying cloud infrastructure is of the provider. This is a cost efficient option for spiky workloads. Coming to private cloud, in contrast to the public cloud, private cloud infrastructure is provisioned exclusively for a single organization's internal use. It may physically exist on the company's on premise data centers or be hosted externally with a vendor. Private cloud gives organizations higher control, security, privacy, and ensures compliance as owners operate the cloud infrastructure. Private cloud implementations allow leveraging capabilities around automation, self service, and orchestration for internal stakeholders. Coming to the hybrid cloud, as the name suggests, hybrid cloud combines private and public cloud models, enabling businesses to tap benefits of both. Organizations can extend core backend infrastructure with public cloud services for things like websites, proof of concepts, temporary overflow capacity, etc., without migration complexity. More broadly, a hybrid approach balances agility and control for flexibility workload deployments across environments. Uh, in simpler terms, you can call a public cloud as a bus accessible to everyone, and a private cloud as one's own car owned by a single person, and a hybrid cloud as a taxi where we can rent it. Coming to the service models, there are three different service models, namely infrastructure as a service, platform as a service, and software as a service model. Coming to infrastructure as a service, it offers essential compute, storage, and networking infrastructure that organizations can leverage on demand without needing to purchase and maintain hardware. Examples of infrastructure as a service services are virtual machines, servers, networking, operating systems that power workloads. Leading providers are Amazon AWS, Microsoft Azure, Google Cloud, Google Compute Engine. Typical users of infrastructure as a service are IT administrators who are in charge of infrastructure operations. Coming to platform as a service, this is the next layer up. PaaS provides complete development and deployment platforms for building, deploying, and managing cloud based software without the need to set up underlying infrastructure. This allows faster application development. Examples of platform as a service are development tools, database management, analytics engines, container services that enable coding applications. Prominent PaaS providers are Salesforce Heroku, AWS Elastic Beanstalk, and Microsoft Azure. Typical PaaS users are software developers. Coming to software as a service, this is the top layer which offers complete end user applications accessible over internet rather than needing any installation locally. This eliminates infrastructure complexity for the businesses. Examples of SaaS applications are email, collaboration tools, ERP, CRM delivered as subscriptions. Leading SaaS vendors are Salesforce, Cisco WebEx, Concur. Typical SaaS users are functional teams consuming these applications. The increasing level of abstraction from infrastructure as a service to software as a service allows organizations to focus less on technology nuances and more on application functionality. Each layer builds on the capabilities below. Let's quickly summarize the service models. Infrastructure as a service provides basic building blocks of computing infrastructure. It has the highest flexibility but requires IT skills to administer infrastructure before deploying software. Platform as a service, it provides ready application development and deployment platforms with pre-configured programming languages, tools, workflows. Abstracts away infrastructure management, so developers focus on coding applications. Coming to software as a service, it provides complete end user applications that are managed and run on cloud infrastructure. Highest abstraction away from underlying technology complexities. So, to summarize, the responsibility for organization decreases as you move from infrastructure as a service to software as a service, while the abstraction layer is increase. So, we have to weigh trade offs between control versus convenience when choosing between self service infrastructure deployment platforms, or turnkey applications as services. Coming to the pros and cons of cloud computing. Cloud computing provides organizations several benefits, including increased agility, lower upfront capital costs, scalable infrastructure, and availability of latest technology. However, dependence on internet connectivity, potential lock in to specific platforms, lack of customization control, and concerns around security of data in public cloud present notable challenges. Despite some risks requiring evaluation, accelerating adoption of cloud computing confirms enables companies to innovate rapidly at lower total cost of ownership. Who uses cloud computing? So, Pinterest uses AWS cloud to easily scale to serve over 250 billion pins to users globally. It allows them flexibility to manage spikes during special events. Cloud also helps them analyze data to understand user preferences. Spotify migrated to Google Cloud Platform to leverage scalable infrastructure for storage and streaming. This provides unlimited capacity to store and stream audio content reliably to millions of users. Netflix relies on AWS Cloud for most operations. Cloud provides vast on demand resources to run data pipelines, machine learning models, media encoding, etc. This allows faster innovation in personalization and recommendations. Overall, we can see that media and entertainment for content production and delivery, retail for e commerce and logistics, healthcare for medical imaging and records, manufacturing for IoT and supply chain, finance for risk analysis, software companies to accelerate releases. These are the industries actively transforming systems to cloud for scale, cost, and innovation. Coming to the conclusion, cloud computing represents a fundamental shift in how computing power is accessed like a utility, allowing organizations to innovatively leverage storage, bandwidth, and processing capabilities on demand. While the cloud model promotes business agility, scalability, and potential cost reduction benefits through resource pooling, security, and compliance risks can deter adoption. With an expected market size approaching nearly $1 trillion by 2030, cloud is compelling businesses to balance the trade offs between disruptive opportunities and safeguards for successful modernization. Thank you.
Hello everyone, I'm Prashansa Evangeline. Today I'm going to talk about the project that I've worked on, that is online hotel booking application. I'm thrilled to introduce you to my project SkyStay, where luxury meets technology, redefining the way we experience hotel. My commitment is simple: to ensure excellence from the first step to the final stay. SkyStay's core functionalities include easy scheduling with transparent room availability, peak season highlights, and discounts. The efficient hotel search allows users to find perfect accommodation based on location, price, and amenities. Stay offers a favorites features with notifications for exclusive deals and services post booking, empowering users to make informed decisions. Guests can At SkyStay, we prioritize security with robust multi-factor authentication, encrypted and secure storage, ensuring your peace of mind. Platform boasts an intuitive UI UX accessible on multiple devices, featuring guided workflows for tasks like booking and canceling reservations. Performance is at the core, ensuring fast response times, supporting up to 10,000 users simultaneously with database queries executing in under 50 milliseconds, and for an impressive 99.9% uptime for consistent user access. The architecture comprises three layers: the client layer, representing user interfaces like web or mobile apps, and API gateway, which facilitates communication. The application layer manages core business logic through microservices like user, hotel, payment review, and notification services. This layer interacts with data layer, infrastructure layer, external components layer, security measures layer, and CI/CD tools for efficient and deployment. This comprehensive structure ensures a robust, scalable, and secure application ecosystem. This is the flow chart. The process commences with logging in or signing up, branching based on their status. If identified as a regular user, they proceed to the hotel having administrators to manage hotel listing reservations made by users. Regular users initiate their journey by searching for hotels based on their criteria. Following this, they can view detailed information about the listed hotels, choose a room, and define its availability. If the room is available, the process advances to the payment phase, where users make the necessary transaction. Post payment, users receive a booking confirmation, and the system seamlessly integrates. Pursue feedback and reviews, read about other experiences, and contribute their own post-stay reviews. This comprehensive process concludes with the overall enhancement of user engagement and satisfaction. Now let's talk about the technology that powers SkyStay, GraphQL. Its precise fetching single endpoint contribute to a seamless experience, and efficient relationship handling make it a robust foundation for the project. Few code snippets that we have implemented in the project. The first one defines a Spring Bean for a password encoder using bcrypt, which is a hashing function that's secure for storing passwords. The second one handles the registration of new user accounts. It checks if the email already exists, creates a new user object, encodes the password using the previously defined bcrypt password encoder, and saves the user configuration that sets up an authentication provider. This is the MongoDB Atlas interface, which is a cloud database service. It displays a database with 4 collections: bookings, hotels, rooms, and users. The interface provides an overview of each collection, including the number of documents and data sites, which indicates the application is for managing a hotel booking system. For a hotel, it includes fields like image, name, description, and manager, with the manager being referenced to the user schema. The rooms field is an array of references to the room schema, indicating a one-to-many relationship between hotels and rooms. The schema is part of Node.js application for managing hotel data. This is a similar booking schema, and this is a room schema, and this is the user schema. This is the login page of the website where user has to log in with the email and password. If the user is new to the page, they have to access the registration page, give all the requested details to register into the web. This is the home page where the user needs to provide the input and enter the hotel name or location which they want to travel to, the check-in and check-out date, and the number of guests. Has home, bookings, edit account, and logout options. The search hotel page where this is what you get when you search for the hotels, the hotel names, and this shows the price, the occupancy, and the date it has been added on. And this is the booking details page. This is the booking confirmation page. This is the hotel booking page. Coming up, the key achievements is that the project successfully handled data scaling, prioritized security for trust and reliability, simplified transactions with seamless payments, adopted a modular design for flexibility and growth, and ensured API connectivity for integration and expansion. Thank you.
The topic of my project for today is shooting analysis in USA using data mining techniques. This project explores the frequency and causes of shootings. Throughout my analysis, I will be exploring trends and frequency and types of shooting across different regions and groups. I did to divide the task into 4 different parts, namely data preprocessing, data visualization, data modeling, and testing phase. To the data preprocessing, these are the 5 important steps which are involved in performing the data preprocessing. First one is data cleaning. It is identifying and handling missing and null values, dealing with outliers, and removing duplicates from the dataset. Data transformation. This involves converting the data into suitable format for analysis. For example, scaling, normalization, or binning. Encoding categorical variables is nothing but converting them into numerical values that can be used in the analysis. Checking for the data consistency. This is to ensure that the data is consistent and reliable by cross-checking the data against external resources. And finally, there is feature selection. This is a process of selecting relevant features from the dataset and removing any unnecessary features. To the data visualization of accomplishments, we have calculated null value percentage in each column and found that there is a maximum number of null values in the race column. We also successfully searched for the large dataset to improve the visualization techniques. Here we have used the shooting analysis data from Kaggle, which ranges from year 2015 up to 2022. This is the biggest and largest dataset available on the internet regarding the shooting analysis. Moving on, we have census data visualization. Here we can see the plot for census data visualization. We requested the API key from the census and got the key. Thus, we have used the state-wise and race-wise data from the census, and we used it to perform various visualizations. Let us take a look at some more visualization graphs. The first one is shooting versus state. We can see that the California has the highest number of shooting incidences occurred as compared to the all other US states. Next one, the total population of the states distributed according to the race factor. Here we can see using different numbers, I have displayed the percentage of each races, for example, white, Asian, native, Hispanic, and others, etc. Coming at the geographical representation using age factor, we can see that the age between 18 to 40, which is indicated in the red color, has the more number of people have died in this age group. Now, when we look at the age distribution using the histogram, we can see that the age is represented on the x-axis and number of shootings on the y-axis. The analysis revealed that the majority of individuals involved in the police shootings were young, and with most falling within age range from 20 to 45. There are the few risk areas which we need to coming at the result part, as we have studied the linear regression and analyzed the causes of death, we can conclude that based on the previous data, the visualization analyzes the trend of shootings over time. Using this regression line, we can see that how the number of shootings has changed. According to the model, based on the historic data, shootings should increase by 2022. Upon reviewing the graph for the top 20 cities, it was found that Chicago, Houston, and Los Angeles had the highest number of murders. The word cloud for Chicago revealed that most common causes of death were related to the gun violence. We also analyzed the weapons used for the killings. The analysis of this data revealed that while some individuals had knives or toy weapons in their possession, the majority of the victims were killed by gun. Interestingly, in many cases, no weapons were found on the victims. Thus, this analysis underscores the need for law enforcement agencies to adopt effective de-escalation techniques. In conclusion, this analysis sheds light on various manners in which individuals were killed or injured during police shootings and highlights the need for greater transparency and accountability in such incidents. We also have learned how to perform various visualizations, linear and time forecasting, and how to use the statistical data to make predictions. In future, we want to further study network analysis and text analysis. Thank you so much for your time and attention today. I hope you found this presentation informative.